All right, looks like we're live, and I remembered to turn my microphone on. We're all set. Welcome back to my game engine development stream. I am, shocker, working on a game engine. Yesterday we got started on this guy. We were working on the scene view, which is on the left side. On the right side, I've got the game view, which is just running the game code as if it was the shipping game, and that's just a simple game state right now, where I've got the clicking and dragging the mouse moves the camera, and you got ASWD, and the Q and E keys move up and down, and you hold shift and stuff and whatnot. Basically, just loads the scene. Yesterday we got scene loading and unloading working. So if I go to file, close scene, the game is still running. The scene view is still here, but there's just nothing in the scene at the moment. And if I go to load it back up, there we are again. You can't really see the other sprites, but off to the sides here, we got Madeline and Hollow Knight. I keep calling him Hollow Knight, even though I've played the game and I know that that's actually not his name. But yeah, we spent a while working on getting input set up for the scene view, utilizing the game engine code, and then after a while kind of figured out the hard way that that's actually a cursed problem. It's what I wanted to do is I wanted to have the game engine be encapsulated, so that every update we update the editor, and then we update the game. And if I go back to runtime.cpp, I can show what that looks like here. So we start the IMGUI frame, we update the editor, we then update the engine, and then we end the frame, and that's it. It's a simple run loop. But the reason why running editor input through the engine is cursed is because between the start and the end of this run call on the engine side, it handles all of the raw input that it gathers over the course of the frame, and then flushes it, and so the input's never available for use outside of the engine. There were some other problems as well, so I've resolved to do input a different way, and that's to just do another input layer. So inside of the editor, we're going to be looking at adding input handling directly in the editor, separate from the game altogether, and that's going to require a little bit of work, because I'm having to deduce. I'm having to figure out a good way to get the focus to be either on the game or on editor code. But let's start with that. I'm going to go to the window code. So this is actually where all the mouse and keyboard input is gathered. When you're dealing with something like an Xbox controller, you normally will pull that input using DirectX. And I do have that set up somewhere. I think that's actually just handled on the engine side. Platform input. Oh, good. Oh, there's a call for get platform input. Get raw input is the call, and that's on the engine side, and basically on Windows it just pulls the input from Xinput, and on Mac OS I think it does the same thing, except for it's through the game controller framework, and then we just handle platform events the same way that we do on Windows for the keyboard and mouse. On the Windows side, we're going to need to divert some of these messages from that past IMGUI, divert them from the game layer when it is important. I'm still a little bit undecided about how to do that. So let's talk through the problem. So a window procedure is basically just the function that receives messages from Windows. Windows will tell it when the mouse is moved over the window, whether you've clicked on something, whether you've resized the window or moved it, things like that. And the way that you handle them is basically just take and make a switch statement where you pass in the second parameter of the procedure, and then you handle each case. And then if there's a case that you don't want to handle, you just return the default window procedure. And this is what the window procedure would be if you didn't define your own. Now, in the case of an IMGUI application, the way that you do it is you, instead of just directly handling the events you want to, you tell IMGUI to handle any of the events that it wants to. You literally just pass through the parameters from your window procedure into IMGUI implementation window proc handler, and that's its window procedure. If it returns true, then we return true, and if it doesn't return true, that's IMGUI telling us that it has an event that it is not handling, and it is up to us to handle it if we want to. So on our code, if IMGUI is not handling an event, we handle it down here. We have a erase background message that we return true on. This has to do with preventing flickering when clicking and dragging windows. It's an OpenGL Windows DWM thing. We have sizing, so we tell the editor to rerun its loop if the window is being resized, and that allows this to update the contents of the window while we're clicking and dragging on the border. We have close for when we click the close button on the upper right, and that just dispatches an editor quit requested message, which we handle through the enterprise event system. Activate app, we handle input mostly, but we handle when you bring the app back into focus. And then we have character messages, which in this case we just dispatch to the engine, so that the engine can handle keyboard input if it wants to. That's on the game layer. So this is one of the things we'll have to deal with. Then there's mouse move. And so this has to do with updating the mouse position, which is another form of input. And as you can see down here, we call EP events dispatch to send that data to the game layer. So this is another message that we may have to intercept. And this is probably the most important one here, WM input. This is the raw input API. It's a little obtuse to look at, but the gist is that when we create the application, we register with Windows. We tell it that we're interested in input messages from the raw input API, and we start getting these WM input messages. So the way that I have it set up right now is that this is just keyboard and mouse. I'm not getting gamepads or anything through WM input yet, though I may in the future. And so we basically just go through these steps of casting the RI data pointer, using this call to get raw input data to the correct type, and then we can obtain a raw input message that we sent to the engine to process. And the reason why I do it this way is to decouple the input handling code from the window code. But this input is, the important takeaway here is that this input is actually not handled in the editor layer, it's handled in the game layer. And we're going to need to supplant that and handle this stuff inside of the editor layer as well. And it looks like those are the three events that we actually care about. I think we can probably do away with key character and key mouse move, or sorry, not key mouse move, WM character and WM mouse move. I think we can ignore those for now. And the main reason is because the cursor position of the mouse is something that we can get from IMGUI. And when we're dealing with text entry, we can use IMGUI for that as well. IMGUI has if we go to its examples, there's a section for text entry somewhere. Inputs, capture override, dragging mouse cursors. I know there's a example, console log. Surely there's an example. Oh, here we go. Text input, and then we got multi-line text input. So like all of this, where I'm able to type the text into this box here, that's all handled through IMGUI code, and we can utilize that whenever we need to have text entry. So we can ignore WM-char messages. So it really comes down to just this, and there's only a couple of things that we care about out of it as well. We care about the mouse delta, and we care about the mouse button state, so whether a button is held down or not. Though now that I say that, I think actually the mouse state is down here in the widget. Might be a little hard to see, but we can see the current mouse position in terms of window space. We can see the mouse delta in terms of pixel space, and that's the thing that we can't use, that we need raw input for. And we can see which mouse buttons we've held down and for how long. And we get a message from mouse clicked and mouse released as well. We also have mouse wheel movement. So yeah, actually, literally the only thing I need from the messages is the raw mouse delta, because that's the only thing that IMGUI doesn't expose to us. Because the reason why this is important is because first, there's subpixel motion on the mouse that we need to capture. If we have a high DPI mouse, we want to be able to use that for controlling a 3D camera. But also, like, if you see what happens with my cursor when I move it to the left-hand side, I stop getting the delta, and that's a problem. So yeah, I guess that does simplify what we need to do. Essentially, we just need to store the data somewhere, and then find a way to avoid passing the input to the game layer if we're not actually in the game. So one of these is easier than the others. So we'll start there. Let me get a location set up in the editor where we can store the data. I guess a logical place for this would be the runtime, but like there's no point for me making an entire input system if it's just to handle this one value. Let me put it in the window code. I think that probably makes sense because we deal with all the other window messages here anyways. And I can change my mind about it later if I want to. So we'll make this a public member. This code is never seen by developers using the enterprise engine, so it's okay for me to make something public if it's dangerous to modify it. We're going to make a static, I guess we'll bring in a GLM, include glm/glm.hpp. We can make this a static glm vec2, and we'll call it raw mouse delta, and we can use that. There we go. We can use that in the window layer to store the mouse delta for use elsewhere. So here we'll do. Are we already in the? I'll do this down below where I'm actually in the right space. So, namespace editor, and we'll say window raw mouse delta. This is also a GLM vec2, and I'll initialize it to. Actually, I'll just let it default initialize. All right. So down inside of the window messages, this is where we got the raw input API. So normally what I do is I just take the raw input data and I just pass it directly to the game layer using EP-events dispatch. So I'm going to need to have a condition here, something along the lines of if runtime, or if is game view focused, or something like that, right? I don't actually have a tracking variable like that quite yet, but we'll need to conditionalize this code based on whether the game view should actually be receiving this input. But if it shouldn't be, we'll need to access this raw input data and do something with it. So let's take a look at how I handle this in the engine layer. And that's handled here underneath input handle platform events, and this is on the Windows side. There's a corresponding event handler for Mac OS. And we do quite a bit with this because this can either be a mouse or a keyboard message. So this first thing we do is we check the data header for check it to see whether we're dealing with the mouse or the keyboard. This whole block is dealing with translating V keys into enterprise keys. We can skip that all and we can just take a look down here. So this is getting the state of the mouse buttons. This is getting the delta movement, and this is actually what we care about. So it looks like the data is available inside of ri data .data.mouse .last x and last y. And we can actually just ignore all the rest. This is all we care about. We don't even deal with positions in here. Positions are handled by WM mouse move events. So I'm going to copy this out, and we can use it in here. So we're going to need to take and translate raw I data into the correct type. So in this case, we'll be using Reinterpret Cast. Reinterpret Cast. We just need to cast the RI data pointer to a raw input pointer, like that. And then we can access the data mouse last x last y. Cool. So these are the deltas that we care about. So that's part one, is to actually get the data that we need. I might change how this data is accessed, because right now it's a public member of the window class, and that's not necessarily a great way to do it. But you know, particularly because of how Mac OS messages work, this probably won't scale very well or be very portable. But we're worried about getting it working first, and then we'll worry about elegance later. So the next part is, how do we ensure that we only pass the data? How do we ensure that we only pass the data to the game when the game view is in focus? Because we don't actually have the ability to track that here. This is just the window procedure. This will occur whenever we pump Windows messages, which is by definition outside of an IM GUI frame. So we're going to need to have some state set up for tracking whether the game view is in focus. Let's take a look at the game view code first. So normally we check to see whether the window is in focus using this. IamGUI is window focused. You invoke it in between the begin call and the end call of a window. So everything that happens between IamGUI begin and end, that is all the code that sets up the contents of the game window. And if you invoke is window focused in there, which we do for the sake of handling pass-through of the mouse, then we, if we in that case we I just got that feeling that I've overlooked something. I can't really remember what it was I was looking for. Anyway, so what we're going to probably have to do is we're probably going to have to store the return value of is window focused into a variable somewhere. It feels like there probably should be another way in IamGUI to know whether the game view is being used. We do have a unique identifier for the window, so whenever we pass in the name, by default that is hashed and used as a unique identifier for the window. So maybe let's head back to the code here and let's see if we can get this information from IamGUI. So let's scroll down a little bit. IamGUI window focused. It doesn't look like we've got the ability to set window focus, say keyboard focus. But I'm not actually seeing anything that looks like a way for you to check focused. Let's Google it. Maybe Google has a different idea. Because it'd be nice if I didn't have to track this myself. It would be really handy if I could just pull it from my IamGUI. Okay, yeah, and as recently as 2018, which was 4 years ago, but whatever. It looks like Omar, the author of Dear IamGUI, was indicating that, or was agreeing that IamGUI is window focused is really the way to identify this stuff. So what we'll need to do then is we'll need to make a variable which we can store the value in. So I'm thinking we'll put this inside of the game view namespace. So let's go to game.h, and we'll make a bool, I suppose, and we'll say is game or is view focused, and then we will Well, it's declared here, but this is not a class, so we're actually going to need to use the extern keyword here, with the correct spelling, of course. So if we make this an extern bool is window focused, we can then define it inside of game.cpp. We can do that up here. Bool is window focused, and we will set its default value to false. Cool. And then inside of the window procedure class, we can use it. So we'll say if game, I suppose it's views game. Views game is window focused, and we're going to need to add the section in particular. Include views game.h. So if views game is window focused, then we should be if the view is not focused, then we should skip this section and handle it like normal. Yeah, that makes sense. Yeah, so let's rearrange this a little bit. Okay. So now the way that I've just rearranged it is that if the game is in focus, then we pass the input to the game layer. Otherwise, we will store the mouse delta here. Yeah, I think that makes sense. Well, actually, there's a slightly different. I'm thinking this problem through as I'm typing the code, and I'm just realizing now that we actually don't care whether the game view is focused when we're dealing with storing the mouse delta for the scene views, because when we go to handle that input, we are already checking whether the scene view is in focus. Whereas that code doesn't exist inside of the game layer because the game code is unaware of the editor. So, in other words, before we pass things to the engine for the engine to handle, we do the checking for the engine. When we do the input for the scene view, and there's probably going to be multiple scene views by the end of this, we just store the data and then only access it if the view is in focus. But yeah, we still do need the isViewFocused variable here to avoid dispatching to the editor or to the engine layer when the view is not in focus, because we're only ever going to get to this state of the window procedure if the IMGUI layer says that it's not handling the input. Yeah. So let me actually do this. I'm going to wrap this whole thing. So if we get a Windows message, sorry, if we get a Windows message for raw input, and dear IMGUI says that we are not going to use it, that I'm allowed to do with it whatever I want, I will then store that data for use in the scene views, and then conditionally send it to the game layer. I think that makes sense. Okay, cool. Now let's actually find a location to save this data. This should be, I think I've got it. Did I put it in the header already? I did. Raw mouse delta. So in here, we're going to say raw mouse delta dot x equals yada yada yada, and so on. Except for, I don't think we've defined it yet. No, there it is. Oh, but the window procedure is actually not part of the window class because it has to be outside, I think. So what we'll need to do is we'll say window raw mouse delta dot x and dot y equals blah blah blah. Yeah, and I don't believe that we bother to scale the delta movement here. We just accumulate it and then process it later. Let's review how I do that on the engine layer, because it's actually a little bit... There's some processing that has to happen on the mouse delta for it to be useful on a frame-to-frame basis. So let's confirm how I do it. Here we go. So this is the input update method. This is called when we go to process the raw input when the frame starts. So at this point, we've already received every raw input event. So we clear the blocking flags. This has to do with input contexts, being able to block lower contexts. Okay, and then this is where we actually accumulate the raw data into a mouse axis accumulator, and then we also track how much time has passed for between the previous frame and this one. So we have a time accumulator, we have a axis accumulator. And then in the fixed update, here we go. So when we actually go to process the input contexts, which we do for each update and each fixed update, we divide the delta accumulator. So we divide the axis accumulator by the delta accumulator. So that means that we're taking the value of we're taking the total distance that the mouse has moved, and we're dividing it by essentially the number of seconds it's been since the last time we measured it. This might seem a little bit unusual to you if you've ever worked with mouse input on another engine. There's a reason why I did this. I wanted the ability to have code be copied and pasted from regular update into fixed update. So update and fixed update are things in Unity. So if you're familiar with those, then you already understand that fixed update is invoked at a consistent fixed rate, and regular update is invoked once every frame. The difference being that you would use fixed update to handle things that are deterministic. That would be things like your physics. So your physics system would be stable across platforms and consistent across platforms. And then you would use the regular update for things that affect what's displayed on the screen. I wanted the ability to have input code that you can copy and paste from one of those to the other. And so the way that I handled mouse deltas is that I took the distance moved, because that's what a mouse delta is. It's how far you've moved the mouse in a frame, divided it by the length of the frame, and that gives you a velocity value. So it'll give you a vector that's not just the distance and direction moved, but it'll give you a vector that represents how quickly and in which direction you're moving, which you can multiply by a speed value to scale. I think that's more useful because it allows you to just like focus on the thing that you're working on and not focus so hard on making it work. So yeah, we're gonna need to head back to the window code. This should probably be a plus equals. Let's double check how we did it on the handle platform events. Yeah, so on platform events we plus equaled on the X and we minus equaled on the Y. Because it looks like we have to invert the Y. So I'll do that here as well. And then I guess every update we're going to need to divide this by the time delta. Which brings up another potential problem. Because similarly to how the input system kind of encapsulates input measurement, it also encapsulates time measurement. So I can't simply do EP time and then time real time. This would be how I get the running seconds or real delta. I can't simply do that because that's only measured after this code has finished executing, or the code for the scene view has finished executing. So if I was to do that, I would be a frame behind. Which might be enough. It might be responsive enough, but I may need to have my own editor side timer as well. And that's not super hard to do, it's just annoying because it's code duplication. But yeah, I'll call this code done. We're getting the raw mouse delta, we're storing it in an accumulator, and then we can use it for what we want during the frame. We've got game view focus tracking, or do we? Oh, we haven't actually set that yet. We've got the variable, but I need to go down to the actual update. And we'll say, okay, we're getting the content area. And if the game view is focused, we need to set that to true. If it's not, then we need to set it to false. Yeah. Okay, that should be enough. That's good. This is good. We just added. Yeah. Okay. So now we have the stuff to make this hostage with. Now we need to handle it somehow. Let's take a look at the time API and consider how best to handle this. Because when we go to invoke any of these time polling items, they're actually only ever updated during time update here. Because this is the time where we get raw ticks and we measure the time delta between the last frame and the current frame. And then we use that for everything else, including timing out the figuring out how many fixed updates we need to call this frame, sending out time deltas for shaders. That's what this is. It's we're passing data to the uniform buffer for shaders to be able to do animated things. We do have this called get raw ticks, which right now is a private, I believe. Time get raw ticks, yeah. So something we could do, and this actually might be useful for game code as well. We could expose the get raw ticks call to the enterprise API. So what that would mean would be, if I was to just move this up here, first I would need to export the symbol, so I need to do EP API, which is the macro for exporting symbols on Windows. What we could do is we could do a call where whenever you invoke it, it will get you how many ticks, like what the current time in ticks, whenever you invoke the code. And then in your game code, you could use this as a portable way to time your code, time the frequency of your code's execution in practice. Probably you wouldn't use this for actual game reasons, but you could use it for performance, for metrics. If I was to expose this, maybe this would be useful for game code, but it would also allow me to access the current time delta without doing a huge amount of work. I would probably also want to expose, if I do this, I would probably want to do this as well. Seconds to ticks and ticks to seconds. These are just conversion functions that take a number of ticks, returns how many seconds that's worth, and vice versa. You pass in a number of seconds and then you get how many ticks that's worth. And that's because the tick length varies depending on platform. So there's I think it's like mock absolute time base on Mac OS and query performance counter on Windows. Those ticks are always the same fixed length, but if you go onto a different computer with a different CPU, they might be different time spans. If I expose these, then I could just directly measure the time inside of scene view without having to worry about when the game layer actually polls. Yeah, the more that I talk about this, the more I think I like this approach. So let's go ahead and expose these to the public API. Let me quickly throw in some documentation so I don't forget to do that later. Given that now it's public, we'll say get time in ticks. Use this, I should say at note, or maybe at remark. Yeah, let's do at remark. Use this to function to measure performance of your code. And then we'll do convert. There we go. It's occurring to me that the return value didn't pop up when I was doing this before. All right, let's put that down there now. Return the time it takes. Cool. And then this one will say convert a number of seconds into ticks. Maybe I should say platform-specific ticks. It makes it a little bit more clear for somebody reading the function that it's platform-specific. I know this seems all pedantic. There's a lot of folks, myself included, that generally doesn't like doing this whole paragraph comment block thing. I specifically do it because I generate documentation in HTML from this. So I actually go through and set that all up so that some developer who's like browsing the documentation can identify what everything does from there without having to go to the code. We'll say and then I'll just copy this whole comment block for text to seconds. Convert a number of, oops, I just reset my zoom. There we go. Convert a number of platform specific ticks into seconds. And now that this is public, I don't think I need to change anything on the definition. I think that definition will be the same. But now we have access to these inside of the editor. Scene.cpp. Inside of here, where we would go to utilize the input, we can now divide it. Though, let me do that in a different location, actually. Let's do that in scene. Well, let's do that in runtime. Here we go. So this is the main run loop. We normally start the I'm GUI frame, we handle drawing the scene editor, then we do the game layer. Before we get to the scene editor, we're going to want to handle scaling the input. So we can do that. We'll do that in a static helper function. I'll say static void scale mouse delta, or scale raw mouse delta. And this will just take the mouse delta vec3 or vec2, which I forgot what it was called already. Let's open up Win32 on the editor. Window raw mouse delta dot x and dot y. Do I have window exposed here? I do. So window raw mouse delta divide equals time I need to import that. Include enterprise time.h, and then we can do ep time ticks to seconds, and then ep time get raw ticks. believe that should be it. So essentially what we've got here is that every frame, when we start the frame, we've accumulated all the raw mouse movement that has occurred since the last frame. That's just a distance. And then here, before we even start the frame on the editor, we use scaled raw mouse delta, which, you know what, that's one line. Let's just do it directly inside of the runtime. We take that distance and we divide it by the amount of time that has elapsed in order to turn that distance measurement into a velocity, a mouse velocity. And then we can multiply that by whatever delta time we've got. I'm gonna need to track my own delta time. Man, there's always another thing. I need to track my own delta time because for the same reason that we need to expose ticks to seconds directly, we can't simply ask for the delta measurement of the previous frame. We're going to need to measure that ourselves. So let's... I didn't really want to do this, but I'm going to have to do a time system or something like that inside of the editor. So let's add a file, time.cpp. And we'll include time.h, except for that's going to be inside of let's put this inside of a helpers section, like helpers slash. That doesn't feel good either. Let's do runtime slash time.h. And we'll save time.cpp in there as well. So we'll add a folder, runtime. We can then move time.cpp into runtime. I'll also move runtime.cpp into runtime. And you know what? I'll move the entry points as well. Runtime.h. Yeah, it's great. I'll throw runtime.h into runtime as well. Though doing that will cause a couple of links to break. So each of these now will be, instead of include runtime.h, we'll say include runtime slash runtime.h. Okay. Oh, but I need to go to CMake lists for the editor and make sure that that's fine as well. Okay, so we got, instead of source runtime.h and runtime.cpp, we now have to do runtime slash. Good. Yep. And then the entry point here. Entry point for both of these is going to be now inside of the runtime slash entry point, and it's runtime slash entry point macOS. That's good. And then I need to add time.h and time.cpp. Like that. Cool. And now those files are added for building. Cool. And then let's add new file time.h. And we'll do prod once, and then we've got namespace editor runtime time. Is that, how do I do the namespace on editor? On editor we just have the namespace editor and then runtime to the class. So in this case we'll just do the editor namespace runtime. Like that. into here. Let's reconfigure our CMake. Okay, and now the build system seems to be finding everything correctly. Cool. So we just added a section for time so that we can add some helpers. Hey, what's up? What's up? What's up? So the helpers that we needed again, which I think I've already forgotten, we need a way to pull delta time, and we need a way for it to need a way for it to accumulate time as well. So let's do void delta time or time. So in the editor, I'll continue to use the same lingo that I use for the engine's time system. So I'll say editor time real delta, like that. And then we'll do update as well for incrementing the time measurement. Yeah, and then inside of the time.cbp, that's the wrong one, time.cbp for the editor. We will then add definitions for these. Ooh, excuse me. Except for real delta actually needs to return a float. There we go. And then we can include enterprise/time.h and get its time access stuff. Let's head back to scene.cpp and start moving some of this stuff into there. Oh, that's oh, in runtime, that's where I started to work. So in runtime, where's my run? Wasn't I doing, what, didn't I add a whole bunch of stuff to runtime run? Oh, this is what I added, okay. So we can get rid of that call. Instead, we would say, instead of including enterprise time, we would go to include runtime/time.h. So this is going to be the editor's version of time, and then we can call time update. This will be the call that actually does the delta measurement, and then we can get the real delta inside of the editor anywhere else that we need it. Cool, that's looking fine. And then inside of here, we will need to actually accumulate the time. So I'll have some members here. Static unit 64T is a 64-bit width type, and we will set it. We'll call this the prev frame ticks. And set equal to 0 at first, and then we'll have current frame ticks as well. Now every update, we need to keep the previous frame ticks. So I guess at the very end of update, we will do pre-frame ticks equals current frame ticks. And at the start, we will do current frame ticks equals EP time get raw ticks. Okay. And then we can get the amount of time that has passed by doing current frame ticks minus previous frame ticks. So we can pre-calculate the delta in seconds. So this will be the real delta. Do you know what it's like to develop for consoles? What kind of compiler they use for those and what standard library support is like? I don't really have any experience with that. However, my understanding is that you have to use compilers that are compatible with the platform. So you're by choosing to develop on a console, you have to play by their rules a little bit. So you may have to use a specific compiler depending on the platform. And in general, standard library stuff is like if you're working on a console, odds are good that you're probably not going to be using the STL or using the C++ standard library. That's the sort of area where you start to get into really high performance, and you want to be using something maybe like EASTL or something like that. The short answer is that I don't know. I don't know whether you can use the STL on a particular platform. I would presume that you could, but you probably won't see it in practice. The STL isn't as bad as it used to be. There was a point in time where it was like a lot of high performance applications. You would have to write your own algorithms and just not use the standard template library because that stuff was like it was meant to be portable really, and it wasn't really super well written. That's not the case as much anymore, from what I understand. But there will be a point where once I get this engine actually making big things, I'll probably get to the point where I do some benchmarking and find that the STL calls are what's taking the most time. And at that point, I might either start to write my own stuff or just bring in something like EASTL, which is designed for use in games. But yeah, here we go. Now that we've got the ticks from current and previous frame, we can now say current frame ticks minus previous frame ticks, and we can convert that into seconds using EP time ticks to seconds, like that. Okay, so now the editor has its own time delta measurement, and that's, I got mixed feelings about this. This might do janky things to the stability of the time steps measurement in the engine side, because we do the editor's stuff first. But you know what? That's actually the same as it was before. I'll allow it. Cool. So current frame ticks, real delta, previous frame ticks, and now we've got a real delta that we can just return. That's looking sweet. And now that we've got that, and in the runtime, the editor runtime, we are now calling time update every time we do a frame. We now have the ability to pull the current time inside of one of these views. I'm going to go ahead and add a couple of input files in the editor, because you never know, I might need to expand this in the future. So I'll add an input.cpp, and I'll add a input.h. You know the drill. We do pragma once on the input.h, and then we do include input, runtime/input.h on the cpp file, and then we need to add these files to CMake lists for the editor, which we'll do that right here, like that, and save. CMake is reconfiguring. It's going to find these files now, and IntelliSense will work a little bit better, though not much better because it's IntelliSense and it never works completely. And then inside of here, we'll do a namespace, and the namespace will be editor input. And inside of here, we can do all of our input-y things. And let's do a method for void get. Let's do void update first. So this will be where we process the mouse delta, because we have to divide it by the time duration every frame. And then we'll have a void get raw mouse delta. But not a void, it has to be a GLM return value. So let's do include glm/glm.hpp, and then we can have it return a GLM back to get raw mouse delta. Damn. And then inside of input.cpp, we'll simply define these. But I need that namespace as well. Cool. All right, and then we'll define these in order to get everything working correctly. So I'll need the access to the time system here. So we'll do include runtime/time.h, and then we can, in the update, take and divide out the accumulated stuff. So we'll go to window. Oh, I could probably move that stuff out of window now. So I was using window raw mouse delta. I can now do input raw mouse delta. And then I can take and move its definition. Oops. From here to here. Get rid of the window thing, and in window.h, we just get rid of the member. Good. And then we need to declare it inside of this namespace. Bam. Oh, but we actually don't even need to do that. We can just, inside of here, we can just use this as a static, and then return it. This sort of code is the reason why I love C# properties. I wish we had something like that in C++. I'll have to try out C++20's modules as well, because presumably modules help mitigate having to do code duplication between your headers and your CPP files, but I haven't really looked into it yet. Cool. And so during update, we take the raw mouse delta, and we basically just divide it by time pill delta. And then at the end of the frame, we need to we need to set it back to 0. Now we need to set the accumulator back to 0. Okay, let's head back to the window code, because I think I'm catching up now. So previously we were just using one value, raw mouse delta, for the data that we gathered from that we gathered from the raw input layer. What we're going to do here is we're going to do 2 values. So we're going to have this private one, which is what returns with get raw mouse delta, and then we'll have this public one, which will be I guess it would be a GLM vec2. This would be raw mouse accumulator. I think CMake's still working on modules. I don't want to try a module without CMake support. Is that the case? Because like you don't have to specify it as a module, right, for it to compile. Maybe I misunderstood what modules do. CMake can't set up the command line for compiling a module. If that's the case, then yeah, that makes it a little bit harder to work with. So we declare raw mouse accumulator as an extern, and then we define it here. And then we can access this inside of the window code. Input raw mouse accumulator.x.y. Except for I need to include the header, so let's do that up here. That would be runtime/input.h. And then we should be getting, yeah, there it is, input raw mouse accumulator plus on the x and minus on the y, because we have to flip it so that positive is up. And then back in here, when we do the update, we now, instead of dividing and reassigning, we take raw mouse delta and we just set it to be raw mouse accumulator divided by real-time delta, and that will give us the inertia of the mouse basically for this frame, which we can then multiply. Oh, hang on. I'm not doing fixed time steps in the editor. I actually don't need a lot of this infrastructure. In the engine, I have it's dividing by the time delta so that it can be re-multiplied by the correct time delta. So there's a handful of different ways that this might be used. Inside of the regular update function, when you're updating once per frame, you might either use the real delta or the game delta. So you may want to scale the response to your mouse depending on which timeline you care about. And then if you're running from fixed update, it'll give you the fixed time step that you're going to need to remultiply against. Also, you can scale it by game time. So it's important in the engine layer that we separate out, that we actually take the raw mouse movement and we convert it into a speed, so that you can rescale it to the correct time frame that you're going to be using it in. But we actually only have one time frame in the editor. I just realized that, because we're not doing fixed updates in the editor. The editor is all, it doesn't have any deterministic code. The stuff that's deterministic is in the game layer. And we're not dealing with scaled time either, because everything we do happens in the real world with us. We're not time dilating your mouse input. So this actually is probably way simpler than I've been making. Let me get rid of some of this stuff. I can make this an extern again. I still do need to clear it periodically. So I still do need the accumulator for a different reason. I think they need compiler support to collect file dependencies, info to build modules in the correct order. I think MS Build has done the module stuff, but yeah, hopefully it won't be too long. I've been hearing lots of positive things about C++20, so I am really interested in that. However, I feel like my personal, as much as I love C++, my personal feeling is that it's time to go back to the drawing board. I think that you can keep making C++ better, and that's good for C++ users, but the adoption rate is going to be terribly slow by companies to use it anyway, because that's how it is. You don't just jump to the next big thing, and I feel like for the sorts of applications that people use C++ for nowadays, the needs are so completely different to the way that people's needs were back when C++ was gaining popularity. I think we should just kind of start over, to be honest. So I'm more interested to see how languages like Jai or Google's what's it called, the new one, Carbon, to see how those replacements turn out. But we'll see. I still do need an accumulator, and that's because I need the ability to dump the accumulator every frame. So what we're going to do here is we're going to say raw mouse delta equals raw mouse accumulator. We say raw mouse accumulator equals 0. Except for it's a GLM type, so we use a vec2. And then this data will be available for use elsewhere. I don't need the getter now. I don't need this to be static. I just need a public global, like that. So the accumulator will be filling up with Windows messages. The raw mouse delta will be set to it at the start of each frame when this is dumped. And then if a resize event interrupts the main editor loop, the accumulator will still keep accumulating mouse input while we use the old mouse input, if that makes sense. Yeah, and these need to be marked as external, like that. Okay, get rid of the getter. All right, I think I'm on track. And then inside of here we get time update, and then we'll do input update. And we will do include runtime /input. Okay. Good. All right. That should be largely where we need it. We're not doing any time scaling anymore. The raw mouse accumulator is being populated by the event, by the WM input raw input API event. So I think that's all the data we need for the scene view to start doing stuff. Let's confirm that everything compiles, because we just had to change a whole bunch of things. So we've got a regenerated build system, and I told it to rebuild all. Surprisingly, there's only 17 modules to build, so that's fine. I thought there was going to be way more, because we were dealing with modifying the header of the time system. I've never figured out and never learned what the extra 10 elements that I don't see in the console are from. Okay, we got a failure somewhere. But like, whenever I go to build, it'll say step 1 out of 1, rewriting CMake, whatever, and then it'll just start at 10. It'll say 10 out of 27, and then start compiling everything. And I don't know what happens in steps 1 through 9, because it never says. Yeah, it's not important. So what do we got? Failed to write the output file, permission denied. Oh, I'm still running the editor. Let me close that and do that again. Okay, there we go. It builds. Cool. So now after doing all of that, we have a way to get the raw mouse delta inside of the scene view. So let's do. Let's include the file. We'll include. It is runtime/input, and then. Do I even need time now? Hang on a second. It just occurred to me the whole reason why I was measuring time. Yeah, I'll put that on the back burner. That's not important right now. But yeah, now that we've got the raw mouse delta, that's the one piece of data that we didn't have from IMGUI, we can go down to where we would update its input. So we've got all of this pass-through code, which should work correctly. We got resize, push, set, clear. This is where we do the camera. So we're gonna need to find a spot. I guess we'll do it right here, where we'll go ahead and update the camera position and the rotation. Let's start with the camera position. That's probably going to be straightforward. IMGUI has a way for us to check is key down. So what do we got? IMGUI key is a type. IMGUI key. Okay, so there's an enum. I can specify the characters I need. So let's do A. And that gives us the bool for the A key being held down. I can do this for ASWMD. Except for I should probably pair them off like this. ADSW, because that's going to be the -1 on the X, +1 on the X, -1 on the Y, +1 on the Y. And then we need... I'll need Q and E as well. Because this will be going, you use the Q key to go up and the E key to go down vertically when you're orientating yourself. Let's set a, I'm gonna just quickly set a constant here. I suppose I can make this a hot constant. Let me do that real quick. And you'll see why I choose to do this in a second. Hotconst/h. Okay. Because that's a library. And then I'll do HC. I guess I would say static HC. And then the type is going to be a float, and then the name is going to be speed equals. Let's start with the speed of 1, and we can change it later. Hot constants are a library that I wrote that's actually pretty cool. We'll see it in action in a second. But now I've got a value speed, and I can do cam position dot x plus equals IMGUI is key down times speed. This might be a little confusing to you if you've not if you've never done this before, but this is returning a Boolean type, and I'm multiplying it times speed. I should probably reverse the ordering on that. Basically, this can evaluate to be a 0 or a 1, so you can actually just use it to use it as an integer. And I believe if it's left is float and the right is integer, then it does a float calculation. Let me double check that. Evaluation order. I always forget these little details. Rules, every value. There's a conversion order that I'm trying to remember. Implicit conversions. Whatever. If it doesn't work, then I'll flip the order around. But basically, I'm just taking the speed, multiplying it by either 0 or 1, depending on whether the key is held down. Except for A is left, so yeah, probably would be a little bit more. Yeah, it probably would be a little bit more correct to do something like that or whatever, but I'm not gonna fuss over it in this case. But anyway, camposition.x has to be minus the movement of A, because that's negative on the A. And then we do something similar for the rest of these. Let's do that. So this is x plus, this is y, and then this is z, and this is minus plus. Yeah, okay. And we got some camera movement going on here, at least. Yeah. And then, yeah, let's just start with that. And then we'll go on to the raw mouse movement stuff. Okay, let's open up a scene. There's Link. Oh, okay. So it's moving. Apparently that's way too fast though. Let me change this up a little bit. I'm gonna go 0.01. I'll start very slow and then work my way up. File, open scene. Okay. So we got some movement. That's cool. Though apparently I've forgotten that. Yeah, because now my Z direction controls are actually going on the Y-axis. So I think I have forgotten to change those axes. It's using X and Y in screen space instead of whatever other space. Let me play around with the camera speed real quick. This thing that I'm doing here, I'm leaving the application live and I'm just changing the value and hitting save. This is a thing called hot constants. You can see on the console it says it's reloaded the file, and now suddenly the speed has changed. I can actually live tweak hot constants, and that's why they're called that. Let's try 0.05. I find it to be handy for hacking things together, but cool, we got some input. Now let's take a look at how input is handled with focus. So right now, it appears to be handling the input no matter what. I need to only handle the input when the view is in focus. So let's do that. Let's get out of here. And we'll go to this code where we actually set this up. I will cut it, and then I will push it into the focus code. I know I have it check here somewhere. Okay, here we go. I'm GUI is window focus. Do I use this anywhere else in this code? No, right here. Let's do turn off the capture. This is important for the sake of getting the raw input message. Wait, no, this isn't important anymore. Hang on. Okay, yeah, this isn't. I have a little bit of simplification I can do. So in the case of the game layer, I have to. IamGUI has to be able to take the control away from the game. So the way that works is that it has a flag called want capture mouse and want capture keyboard, and when those are set to true, we don't pass the input to the game. However, I'm working in the IamGUI layer now, so what I could do is I could just always get the mouse delta, and then I don't have to worry about telling IamGUI to I don't have to set the capture flag to false manually anymore. That's pretty cool. So actually I can get rid of all this code too. Like that. I think. Actually, I might still need the content area button for the sake of clicking and dragging at the same time. Whatever. I'll get rid of that capture flag for mouse because I don't need that, but I'll leave the invisible button stuff going on. Let's run that. Let's confirm that it's doing what we think it should. Oops, I need to open the scene. Here we go. Man, I got the something kind of like hiccups, but not quite hiccups. And cool. And if I don't have the window in focus, so I click out to this area, the keys aren't doing anything. So that's working as we expected. Does it still work correctly out here? Seems to be. Yep. And cool. All right. So that seems to be working fine. The keys still work when I'm clicking and dragging on the title bar, though. I don't think I like that. So yeah, I don't know. It's something I'll deal with later. But let's get the mouse input working now. So if the window's focused, we're going to be responding to input. Let's do. Yeah, so we're tracking the cam pitch and cam yaw are values that we're going to be working with. So this will be cam pitch will be plus equals to the y input raw mouse delta. Actually, I can just do. If I changed the cam pitch and cam y to be vec2, I can just do plus equals raw mouse delta, but whatever, I'll make it explicit. So we'll do cam pitch and then cam yaw, should be the x-axis, like so. And then those are already in use down here for setting the quaternion based on Euler values. So yeah, I think that should be all we need. Assuming that I've not screwed up my input gathering at any point. Okay, look at that. So that's going really fast. I guess that makes sense. I'm just using the raw value and not storing, not scaling it anywhere. So let's scale that a little bit. I'll do another hot constant for this. So if we can tweak it, we'll do mouse scaling, and we'll start with 0.05. Where did they go? All right, scroll right past it. Yeah, so we got the delta here. We'll do mouse scaling times that. Though also, now that I'm thinking about it, the mouse delta already is already multiplied by time. It's if you want to think about it in those terms, it's the speed over. It's essentially the speed over the or multiplied by the distance. It gets you the delta that we've got. But speed, we actually do need to multiply this by the time delta. So let's do that. Where's our time? Did I get rid of it? Oops. Yeah, I've got time real delta I can use. So let's include time.h. And then down here, we can use time real delta. Cool. And that's probably going to make the speed a lot slower, but we can scale it. So let's try this out. Okay, and let's open a scene. Okay, mouse is a little more controllable, but still not very controllable. Let's go into... Wait, hang on a second. Excuse me, I think I just inhaled something. Okay, so... I'm going to take a second to recover. Oh, holy crap. Alright, yeah, I was thinking for a second that it was moving independent of my mouse motion. But that doesn't appear to be the case, it just appears to be moving really fast. So let's head back into here, and mouse scaling. We're multiplying by 0.05. Let's change this to 0.005. See if that actually makes a difference. Okay, it is. So this doesn't currently care about whether I'm clicking and holding the mouse button or anything like that. Oh, wow. I'm dying over here. Give me just a second. I'm going to grab some water. Holy crap. Ugh, all right, I'm back. That was rough. I'm trying hard to not think about what it was I probably inhaled, because it was probably a mosquito or something. Anyway, where was I? Yeah. So we were here in the we were updating the rate of the mouse movement. So we can see that it's responding to my mouse delta. There we go. But yeah, we gotta change a couple of things on the input because it feels a little awkward right now to, yeah, speed-wise. I heard some people say networking should be considered early in game engine dev. What do you think? Would you roll your own socket library or use third party? Yeah, networking is kind of absolutely everything. You don't really have a job unless you unless you know somebody. Though with game engine dev, I would say probably it's because it's a lot more technical, and it's less about, designing things. It's more about just making things work well. You can probably get away with less networking than you could if you were a designer. But yeah, network is the short answer. And I don't really know much about sockets. I haven't really done that kind of code. But probably use a library until you know you don't need to. It's like there's a whole bunch of low level stuff that you'll probably spend a whole bunch of time to try and get to the point that a third party library has already gotten to. So like for me, I personally will use third party stuff if I think it meets my needs. I will avoid using third party stuff for licensing reasons if you have to pay for it and I don't want to spend the money on it. If it doesn't exactly meet my needs, so there's things that I need it to do that it doesn't, or there's things I don't like about how it does its stuff, or if I'm trying to do it as an academic exercise, I'll do it myself instead of getting a library. For that third reason, the academic reason, I almost went on to do my own graphical user interface for this engine editor, but I changed my mind on that because I realized that that's not really the thing I want to be practicing. I want to be doing the game stuff, not the getting a window to dock and undock stuff working. So I went with your IMGUI. So the raw delta messages are coming in at least. It looks like now that I'm scaling the keyboard input by time, it's going way too slow. So let's hop back into the code and we'll change the speed a little bit. I'll change it to 0.5 on the speed. That's going to be a half a unit per second. And that's still very slow. So let's change it to... yeah, God, man. Let's change it to 2 units a second. That's a little bit better. Yeah, that's pretty. I'll change it to. Let me change it to 5 units a second. See what that feels like. Okay, that's starting to feel a bit better. It's starting to get annoying that the X and the Y are in the wrong direction though. So let me look at changing that. So there's a few improvements that we need to make here. The X, Y, and Z are actually linked to the wrong items. Technically, when I push up on the keys, I want to go forward in the Z direction, not the Y direction. So these need to go in a different order. Oops. So that'll be these will now be Y and these will now be Z. Okay. Additionally, the mouse movement is, as long as the window is in focus, it's taking my mouse movement. I'm going to change this to be only adjusted while the right mouse button is down. So for this, we'll do another if statement. If IMGUI is mouse down, I guess that's the one. I'll say it is mouse down, and then we supply the mouse button. So that's IMGUI mouse button underscore right. So I'll do the right mouse when I'm moving the camera around, like we were talking about yesterday. So if the right mouse button is down, then we will adjust the camera pitch, camera yaw. And then with the keyboard input, I should be able to do W as forward and S as back instead of W as up and S as down, which is, you obviously wouldn't have seen that on the stream, but that's what I was doing. Let's rebuild and run. Okay, and let's open the scene. There's the scene. All right, so keyboard is a lot better now that I can actually go forward correctly with that. And now it'll only pan around when I use my right mouse button. Now it feels a little awkward to me, actually. Pushing up feels weird. Maybe it might be because it's slow. Like if I play in the game view, what do I got going on? Yeah, it's still up is up and down is down, but it's just a lot faster. I do quite like the speed that I have it in the game. So what is that? What speed am I using there? Okay, it looks like I actually defined that in the input context data file. So let's open that up. So this is where I defined my game code input stuff instead of hard coding it. So in the case of the look X and look Y, we were using a scalar of 0.001. Which right now my scalar is 0.0005, which is a lot less. I'm going to change it to that, and thanks to hot constants, it should be available right away. Yeah, it's looking a little bit better. It still feels really weird though. Oh, the Q and the E keys are backwards from what my intuition is as well. On this guy, Q is down and E is up. Oh, that's weird. What's happening there? Something weird is happening with the keyboard input. It was like moving without me holding down the key. It was like losing track of the A key for some reason. Yeah, I can't really reproduce that now. That's weird. Oh, I'm trying to right click on the scene view to change focus, and it doesn't do that. Right clicking doesn't change your focus. But yeah, let me swap the Q and E keys. Eventually, these will be configurable. These won't be hard-coded settings that I'm tweaking, because everybody will want to have their own, to adjust their own stuff. But yeah, now it's in focus, and we've got. I don't know. That still feels really weird. Why does it feel so strange? It's like I'm not expecting it to. Camera speed moves a lot faster on the game view than it does in here, and I'm not really clear why. Oh yeah, also, hang on. No, I thought I had spotted. Yeah, so there must be another place that I'm scaling the game raw input. Thanks, man. Yeah, that's totally understandable. Get some sleep. It's nice to have you pop in. Oh, I have a separate look speed scaler in here. Let's take a look. Where do I define that? Yeah, so I'm actually I actually have a separate scaler in here for look speed. That's like player camera defined. Okay, that makes sense. So back in my scene view, I can change the scale to be 0.003 because the look speed on this was multiplying its input by 3. Let's hit save on that. Hot reload should have just... Okay, that's a lot. That's a lot more like I'm used to. It still feels a little weird, but... Thanks, what's up? Me too. Have a great sleep. Oh, something still feels kind of janky about this camera. I can't really put my finger on why that is. Let me open up Unity real quick. Yeah, I'm gonna do a comparison on how the camera feels in there versus in here. Kind of see if I can figure out why the view is sucky in mine. I just don't understand. Of course, it's going to take like 3 years for it to open up this simple Unity project. It feels kind of like it's too responsive, which is weird. But it should be like the same responsiveness as this, and this one seems like it's moving. I don't know, up and down too fast, maybe. Is my field of view the same? Hang on. Maybe there's an issue with my field of view. Oh, I'm willing to bet that that's what it is. No, test state uses 60 degrees on the field of view, just like I do in here. Yeah. I don't know why it took me so long to figure this out, but my Y is flipped. Why did that take me so long to realize? My Y is flipped. I push up and then I'm pushing up the scene, and on this one I push up and I'm pushing up the camera. Why didn't I? I don't know why I didn't put that together until just now, but I didn't. Yeah, so let's take a look at that pitch. Should be minus equals, it looks like. Yeah, so on this guy, pushing up puts the camera view up. Yeah, so that was the issue. I just, for some reason or other, I didn't. My brain wasn't connected correctly or something. Alright, let's try rerunning this. We should be in a better place with that. Alright, file, open scene. Here we go. Yeah, that's better. Okay, that's a weird phenomenon. Like, I was doing fundamentally different camera controls on the game code versus the scene view. But for some reason, like, my brain was like remapping it automatically so that I was thinking that I was doing the same thing, except for I just had that little bit of a, that feels weird moment. All right. Now the only other obvious thing is that I'm relocating the camera in terms of the world coordinate system. So I press W and I go straight down the z-axis, I need to make that relative to the to the camera's orientation. So that means we got to move this code to be first. So we have the camera rotation figured out up here. We should probably convert into a matrix as well up here. I know that I've already done this stuff here in my test state code, so I'm just going to copy it. So here we got the mouse pitch and yaw being calculated. Camera rotation, we need a quaternion for that, and that looks just like this. Bam. And then the movement, we need to have, we need to rotate essentially the right, up, and forward vectors by the rotation of the camera. And so that way we just move in that direction instead of moving in world space direction. There we go. So we get the camera rotation from camera pitch and yaw. We've got the move vector, right vector, and up vector, all being rotated by the by the camera rotation correctly. So literally, we just take a vector that points forward, so positive z, and we multiply it by the camera rotation matrix, which, if you think back to your linear algebra, that should get you a vector pointing in the same direction as the camera rotation. And then we use cross product to get the right and the up vectors, because cross products are like if you have two vectors, the cross product will be the vector perpendicular to the plane formed by the first two vectors. And so I do that here, GLM cross, using the up vector, which is y, and then passing in the forward vector. So whichever way the forward vector is, we find the direction pointing right from it using the right-hand rule. And I think I need to set this back to, I think the right vector value is wrong. Let me think about that. Because the magnitude of the cross product is I believe it's equal to the area of the parallelogram between the first two. So if the camera is rotated to be straight up, for example, then the area will be near 0. Huh. Did I, well, this won't compile, but I'm realizing right now that I might have something weird going on with the camera controls in my test game, and I'm just going to double check that that's actually the case. So let's run the game. And in the game view, what I'm curious about is whether the speed of moving right and left is affected by which direction I'm looking. So I'm looking straight down almost. I'm going to hold down for 1, 2, 3 seconds. I'm going to look back up. And I'm still looking at Hollow Knight. That's interesting. 3. Yeah, and if I hold down for 1, 2, 3. Oh, that's interesting. So the move speed slows down on the left and the right when I'm looking down or up, because unless I'm looking straight forward, the cross product is approaching 0. Okay, yeah, that's not great. So I'm going to need to do this a slightly different way. So instead of doing the cross product for this, I'm actually just going to take and do like I did up here. Not going to do anything super fancy. I'm going to take the movement vector, or the camera rotation, and multiply it against a vector pointing right, which would be this guy. And do the same thing for the up vector, which up is positive on the y-axis. Okay. Yeah, I wonder why I did it that way, now that I'm thinking about it. It seems like a strange way to do this. But let me replace the code here. Yeah. Okay. Yeah, and now we've got the upright and forward vector. The camera position, which I actually spell out the full word campos here. Camera position. We basically set it equal to the we get the axis from the input system multiplied by the game delta times the move speed times the speed boost times move vec. In our case, it's actually a lot simpler than that. We have the speed times the movement, and then we just multiply all of this by the move vec. So camera position, here we go. So this is the move Y, move X, move Z. So we'll do all of this gets replaced by speed times time real delta. And then the is key down as well. Times move vector. So we just move this to the beginning, like so. So we got a vector, a vec3. Or does it have to be on the? I guess that has to be on the right hand side. We'll see if this comes out correct, because these are floats. This is a boolean. This is a vec3. I think it probably will come out correctly, but we'll see. If not, we'll just adjust it a little bit. Cool. And then we basically do the same thing, but for the other keys. Yeah, this isn't super straightforward. I'm gonna once remove the input, so we'll do a float x move equals we'll say equals the negative a key. I guess we'll say we'll do the d key minus the a key is what we'll say. Like that. And then we multiply that whole thing by speed. Okay. And then we'll do, for the Y and the Z move, we'll do the same thing. So it'd be E minus Q. And on Z move, it'll be W minus S. Like that. Okay. So now we've got axes to multiply against, and we can plug those into here. Speed, time, speed. Yeah. Speed times real delta times x move times move back. Though I'm gonna rearrange this a little bit and put x move at the beginning times speed, or times delta times speed times move vec. Yeah, that's looking pretty good. And then we'll do the same thing for the other the other axes. Yep. And we got to replace move vec with right vec and up, or the other way around. Up vec and right vec. Okay. I think that's right. Let me quickly go over this again. So we've got the cam pitch, cam yaw being calculated from the mouse. And we're only adding the pitch and yaw if we're holding down the right mouse button. So far, so good. We calculate the cam rotation from whatever the current pitch and yaw are, which we have to do anyway because we always need the camera rotation for rendering the frame. Then we get the move vector, which is basically just take the forward vector, which is positive z, multiplied by the camera rotation. The same thing goes for the right vector, which is positive x, and then up vector is positive y. And then we get the axes from the keyboard input. So we got the D key on the positive x, the E key on the positive, on the positive y, that would be up, moving up, and the W key on the positive z, because that's forward in 3D space. And then we subtract by the corresponding opposite keys. And then we multiply that by speed. Okay, that's so far so good. Then what we do is we take the move times, let's do times the move vectors, like that. So the move axes times their vectors gets the vector that's in their right direction, times the real delta times speed. That's all good except for the vectors have to be on the right because these are just floats. These are the you have to have the order be correct when doing linear algebra stuff. Yeah, I think that's probably good. And for clarity, I think it actually does look a little bit better to do speed before time. Can't really put my finger on why, but I think that's the case. And I'll put this keyboard input code up close to where we do the mouse input code. Perfect. Okay, let's see how that goes. Cool. Got the scene file open. Keyboard is moving really fast. And it's also moving in the wrong direction, so that's great. I screwed up at some point. So first things first, I got the A and D keys are going up and down the Z axis. It looks like the E and the Q keys are correct. But yeah, the X and the Z axes are flipped for some reason. The mouse still feels fine. What's up with the X and the... Oh, hang on. So X move is A and D. I'm multiplying it by the forward vector instead of the right vector. Y move should be the up vector, and then the Z move should be the move vector. I probably should just rename that to be forward vec, like that. All right, let's try that out. That should be all that it was. All right, open up the scene. There's the scene. All right, so that's that. Now the controls are working in the correct space, and additionally, they are moving in the correct direction as well. It is the move speed is a little bit fast though. So what did I set the speed to? 5. Let's set it to 1. That's way too slow. Set it to 3. That's weird. Set it back to 5. Yeah, I guess it just always was that fast. How fast did I have it going in here? Testing. Yeah, move speed was set to 5. So if I go to the game and play the game, that's really strange. It's way slower feeling in here. Oh, I probably have it scaled in here as well. No, I don't. I have A, S, W, and D are all scale 1. I'm not really clear on why this feels so different, but it does. Okay, so the speed is set to 5. This will be 1 pressed down, so will this. So this will be 0 if they're both pressed down, 0 if neither is pressed down, positive if D is pressed down, and negative if A is pressed down. That all makes sense. We multiply it times the speed. Oh, I'm doing that twice. Okay, yeah, I don't actually need this part. Yeah, so I was squaring the speed instead of just scaling by it. So now if I open the scene, there we go. That's feeling a lot better, a lot more approachable. Cool. So now we got camera input, a basic 3D camera working inside of the editor. There's just going to be one more thing I want to do. I want to set up the shift key to be a speed boost. So what I can do is I can say move vector or move axis times speed times time times the vector. I will do. It'll have to be times some speed boost value. So I'll add an axis here. So we'll say float speed boost equals, and we'll set this equal to 1 plus I'm GUI is key down. Have to capitalize it correctly though. Is key down, and the key we're looking for is shift, left shift specifically. And then speed boost will be 1 or 2 depending on whether you're holding down the key. And then I can take and multiply by speed boost. So far, so good. Yeah, I don't know. Breathing is not very easy today. I don't I don't know how I'm sucking so hard at just drinking a thing of tea, but just inhaled some again. Man. All right. So we open up the scene, 2D scene, and now we've got the camera moving, and if I hold down Shift, suddenly I'm going twice as fast. Okay, so this is good. We're off to the races now. We've got a scene view that actually has its own input system independent of the game layer. The game can set up its own input context and have input handling however it pleases. In this case, they happen to be the same because I modeled this view after it, but it seems to be going pretty swell. So this is a spot where we can start adding things like mouse picking and just start editing the scene. Trying to think of what else we need to deal with before we move on, because there's something I keep doing is I keep right-clicking into the scene view, and it doesn't actually change focus until I left-click. So I have to left-click and then right-click, and that's kind of annoying. So I'm wondering if there's maybe I should be implementing a focus change on a right-click on these windows. Another curious consequence of this is that while this view is in focus, it doesn't matter what I right-click on. It will always move the camera around as long as the app is still in focus. So, for example, if I right-click on these menus, it doesn't do anything there, but it still controls the camera, and same thing goes for this view. So, yeah, there's two things there, I suppose. The first is that right-clicking on something outside of the view probably should lose its focus. And left-clicking. Let's say that right-clicking on on either the game or the scene view causes it to lose focus. So we might be inside of the inspector and we right-click on something in here. Oh, but that's a little confusing. Right-clicking on one of the tabs actually does bring up the other tab. I'm just trying to figure out the best way to limit the input here. I'm thinking I'm specifically thinking that if you click outside of the content area, then it just doesn't use the input. That probably would be the best way to do this, so let's implement that. And we can always come back to these details later. So we have this thing, this invisible button, the scene view content area button. That's specifically for keyboard input capture. Basically, if you're dragging within the window, by default, IMGUI will capture the keyboard input. But actually, now that I'm saying that, I don't actually need this code, because the keyboard input is not being gathered from my window procedure. It's being gathered by the IMGUI window procedure, so that's actually totally fine. But I can still use this block to turn on or off the mouse input. So let's figure out how to wrap this. So if the window is focused, then we execute this code normally. In addition to being focused, we want the mouse input specifically to be blocked if we're clicking outside of the area. So we'll say if mouse down and is item active, the item being the... No, that's not right. Maybe is hovered. Yeah, is item hovered. Then we will do the right-click drag stuff. And for that to work, I need to actually add the item that we are checking hovering for, and that's going to be the invisible button. Okay, so just to review, we've got we're checking to see whether the scene view is focused. If it is, then we can respond to input. We add an invisible button that covers the content area, and we only respond to the mouse input if we're hovering over it with the mouse, and you are right, and your right mouse button is down. The keyboard input will work regardless. Yeah, so let's see if that does what I expected it to. Okay, so far so good. Camera's working fine. If I right-click outside of the window, it's not doing anything. If I right-click and drag on the title bar, it does. Oh, actually, what's happening is a little bit neater. It picks up the mouse when I enter the view. Oh, that's not what I want at all. Ooh. So I guess what I'm gonna do is I'm just gonna get rid of this, these changes that we just made, and I'm gonna worry about it later. Yeah, we'll do it like this. So I'll leave the invisible button there for the moment. I'll comment it out though in case we need it. But the problem with this implementation is that I do need, when you're clicking and dragging, I need the mouse delta to continue to track even if I go outside the bounds of the window. Though, if I do mouse trapping, then it would probably be fine, because I wouldn't be moving the cursor outside of the bounds of the window. It would remain fixed. Actually, you know what? Let's do that. Let's implement mouse trapping. I don't actually know how you do that yet, but we're gonna figure it out. So if the mouse is down, then we're gonna hide the mouse. That's the plan here. So we'll go IAM-GUI cursor. So we have get and set cursor position. That's handy. We also have capture mouse from... Oh, really? Can we just do that? True. It says capture mouse from app. What's that look like? Want to capture mouse next frame. Oh, this is different. Okay, never mind. Capture mouse from app just means that it's we're going to mark it as used in the window procedure. That's a little different. Okay, so we do have get and set on the mouse cursor position. So we got get cursor position and set cursor position. We can use that to just move the mouse back to the place that it was when we started clicking. And then we need to hide it. We need to make the... Yeah, so it looks like we have get mouse cursor and set mouse cursor for that. So let's take a look. We can set to I am GUI mouse cursor type. And there is a none. So we can change the arrow type back to none for this. Okay, I think that's everything we need to do mouse trapping. So we'll need to track whether we had the mouse down on the previous frame. And we also need to track what position we're going to be resetting it back to as well. So what return type do we get with I am GUI get cursor pause? It looks like it's a I am vec2 type. So we'll say static. Well, I'll do this inside of the if. Static I am vec2 previous, let's say trapped cursor pause. And we'll set that equal to, and we'll just default initialize it first. And this will be set when we move into mouse trapping mode, and then reset to it when we are still in mouse trapping mode. So when we hold down the right mouse button, we are in mouse trapping mode by default. So this code will occur when we are in quote unquote mouse trapping mode. So outside of it, we need to. I can do this inside as well. Static bool was mouse trapped. We'll default initialize it to false. But this will track whether the mouse was trapped last frame. And if it was or wasn't, we can handle this a little bit differently. So we'll say if was mouse trapped. So that means we're trapping this frame and it wasn't trapped last frame. We will set the cursor type to be none. We will set the trapped cursor position equal to I am GUI get mouse cursor pause. Wait, get cursor pause? Get cursor position, yeah. Hang on, I think that might be wrong. Okay, it's get mouse pause, not get, yeah. Okay, I'm GUI get mouse pause. And then at this point we set was mouse trapped to true. Cool. So the frame that we start trapping the mouse, we set the cursor position to none, or cursor type to none. We get the position of the mouse and trap it there. And then we indicate that the previous frame we changed was mouse trapped to true, so that way next frame we skip this logic. Cool. Now we have to do the actual mouse trapping part. So we'll say I am GUI set mouse position. Can we not set the cursor location? So we can get the mouse location, but we can't set it. That's annoying. So I guess I'll have to add my own API for that and handle that part myself. But let's start with just making the cursor invisible, and we'll see what that does for us. We won't be using the trapped cursor position for anything. And then outside of here, we'll say else if was mouse trapped. Then we will do I'm GUI set mouse cursor to be I am GUI mouse cursor arrow. Cool, and then that means I'm going to need to move was mouse trapped outside of this if else. Okay, so this change to the code should make it so that the mouse cursor disappears while we're right-clicking on the view. That's not what happened, though. Apparently. I'm not really clear on why that was. Let me set a breakpoint on each of these arrow setting things. Neither of them are getting invoked. That's interesting. So there's a problem with my condition. This needs to be false. Right. So if the mouse wasn't trapped, and we are trapping it now, and then down here it's we are not trapping it and it was. Okay. It's all coming together. Alright. Well, that still isn't working. Let's set the breakpoints. Okay. So we do set the mouse cursor to none. And then we set was mouse trapped to true. We continue, and that's it. And then I don't have the mouse down. It was trapped. Okay, so I think the code is being executed when I expect it to, but maybe I misunderstand set mouse cursor. Let's take a look at the demo code real quick. Input, navigation, mouse state, mouse cursors. Okay. So the demo code here demonstrates examples of how all of these things get set. Mouse cursor 0 is arrow. We have the text input, which is the little vertical I bar that's they use for text entry. The one that I wanted to change it to was none, and I don't see none in here. Let's take a look at this code. I'll search for the text mouse cursor 1 inside of the IMGUI code. Yeah. We should be looking in vendor /IMGUI. Really? Nothing found? Maybe it's listed as an index, not as the actual constant mouse cursor 1. Okay, here we go. sprintf label mouse cursor %d. Okay. All right, so this is where the code actually happens. For every mouse cursor type, we go through character label, label, mouse cursor, %D, whatever. I'm GUI bullet, I'm GUI selectable. If is item is hovered, then they say I'm GUI set mouse cursor to I, and I is going to be the index. So, I mean, that seems right. Let's, well, it seems right, but there's actually an element missing here. There's no none mouse cursor here. There's only the arrow, text input, resize, the hand, and allowed. Or not allowed. Maybe I have to, let me go to the enum. Here we go. None is a -1, so that's why it wasn't showing up in the for loop in the demo code. Let me try, I'm going to try using a not allowed instead of a none and see if that causes it to work. If it doesn't, then I must be doing something wrong inside of this code. Okay, that's interesting. So for a second, you see that the arrow pops up when I immediately go to right click. So that's telling me that for a single frame, it's set the mouse cursor. Oh, do I have to set it every frame? That might be what the problem is. I probably need to set it every frame, and then GUI reverts it after that. Yeah, let me fix that. I'm gonna change this up a bit. Okay, F7. Okay, so now when I right click, it does the no symbol on it. So if I was to do this with, instead of not allowed, do none, it should make the cursor disappear. There we go. Okay, so now when I right click, I can still move my arrow around, but the cursor disappears. So if I was to open the test 2D scene, the cursor disappears when I'm moving the camera around, and that's pretty nice. That is already an improvement. But I do need to trap the mouse where it is. And as you can see, if I go crazy with the mouse camera and I let go, my cursor might appear anywhere. It might appear outside the window. It might appear on the edge of the screen. If I was to go down to the bottom right forever, then let go, then my cursor wouldn't even be visible. So that's got to change. All right, I'm going to do a quick Google search to see whether or not DRI GUI has the ability to set mouse cursor position. But if it doesn't, then I will just have to add it myself. I'm not immediately seeing anything regarding this. This question here was posted about the use of glut, GLUT. That's the GL utility something or other. I forget what it's called. Toolkit or something. It's a little bit like GLFW, except for it's very OpenGL oriented. They work really hard to to give you a whole bunch of flexibility with OpenGL stuff. So I guess interpreting Omar's answer here, I suspect that the answer is that you have to set the cursor position yourself. In IMGUI, implement free glut new frame. You probably can want to call glut set cursor based on the current value of IMGUI set mouse cursor. All right. So I guess we'll have to set the. Wait, what? Yeah. So I guess we'll have to do this ourselves. So we're gonna need to tell Windows to move the cursor back every frame while we're holding down the right mouse button. Which isn't great, but whatever. To do that, I think we'll do. We could either put this in the input code or put this into the window code. I'm leaning towards putting this in the window code, but let's look up the methods that we'll be using. So on Windows, that's done with a call to bool set cursor position, where we just pass in an X and a Y in screen coordinates. On Cocoa for Mac OS, that's done by maybe a member method of the NS cursor class. Well, that link's broken. This guy on Stack Overflow mentions CG warp mouse cursor position. Let's look that up. Here we go. Moves the mouse cursor without generating events. Okay, that's good. Is this in Swift? Let's do it at Objective-C. Okay. This looks to be pretty much this looks to be C code basically. So we can do this from a CPP file. All we need to do is to include the header, the appropriate header, and then pass in the new cursor position as a CG point struct. So this doesn't even need to be done in Objective-C. Cool, so I can actually do this code in any location I want. So let's do it in the input section. I'll say void set mouse position, or let's say set mouse cursor pause. And then we will pass in screen coordinates. So from IMGUI, we can get the mouse cursor position with IMGUI get mouse position. That gives us an IMVec2, which is a what type again? IMVec2. It's got float X and Y. Okay, so that takes floats. So this method is buy-in for IMGUI, so I'm going to have it accept floats as well. In fact, I could probably even have it accept the IMGUI type. But I won't, though. Not for now. And then in the .cpp file, we'll implement it. Void set mouse cursor position, float X, float Y. And then we, for this one, we'll do, we'll need to include we'll need to include platform-specific code for this. So instead of breaking this off into individual files, I'm going to do some conditional compilation. So we'll say ifdef underscore win32, 32, not 23, and ifdef, actually it'd be if defined, I think it's Apple, and defined I can't quite remember. Let me reference my documentation real quick, where I actually happen to know I wrote it down. It seems to be taking a while. Here we go. Oh, that's strange. Huh. Gen docs. Windows. It seems to be running, but I'm not getting any. Okay, there it goes. For some reason, the output wasn't coming up for a while. It's underscore underscore Apple underscore underscore mock for Macify stuff. So on here, we're going to be doing an include for this guy. This requires Windows.h, so we'll do pound if indef win32 name and name. I believe that's how it goes. I've got the whole word on. Yeah, win32 underscore lean and main. Then we will define that, and then include windows.h. now we have the windows.h header, and we can do we'll do more conditional compilation inside of here. And we will do set cursor position to be integers x and y, and we can just implicitly convert from the float x and y to that. And then on Mac OS we'll have our own thing for that. So I'll just go ahead and add that block for setting the cursor position. And actually, I could probably just add that code. CG warp mouse cursor position. But I won't. I'll just deal with that later. Okay. Cool. So now we've got a call for set cursor position that accepts the float x and y, and then on a platform-specific basis, it'll move the cursor to that position. So whenever we're holding down the right mouse button to do the camera movement, we'll set the mouse cursor to none, but we will also set the position to be the position it was when we first started doing these. So in order to do that, I will need to do a static bool. This is the code I was trying to write earlier. Is mouse trapped equals, or I should say bool was mouse trapped equals false. And then at the end we'll say was mouse trapped equals true. I've got a phone call coming in. Give me just a minute. Alrighty, I'm back. My sister was locked out. I had to let her in. Cool. And where was I? Yeah. So we need to we need to store the position of the mouse when we first click the right mouse button. So I guess. Yeah, I guess we'll need to move this bool out here. So we'll do static bool was was right mouse down. Was false. And then inside of is mouse down, we'll say inside of here we'll say if was right mouse down is false, then we will get the trapped position. And that'll be another static. Another static up here. We'll do static I am vec2 type trapped mouse pause, and we'll set trapped mouse pause equal to I am GUI get mouse. Wait, I am GUI get mouse pause. Cool. And at the very end, we'll say was right mouse down equal to true. And then we have to do an else. So this is if the mouse is not down, we will set was right mouse down equal to false. Cool. And actually, just because it's the one thing, I'm actually going to do without the braces on that if statement. So we've set the mouse cursor, and now we need to set the mouse position. So for this one, we're actually going to use the input method that we just created, set mouse cursor pause, and this is going to be the trapped mouse pause.x, trapped mouse pause.y. Okay. Now, assuming that the coordinates that we get back from trapped mouse pause from IMGUI, assuming that that's in the same space that the coordinates of Windows uses, then we should see that the mouse actually remains still when we go to right-click drag. So let's give this a shot and compile it all. Okay, it compiled fine. And if we go to open the scene file. Okay. I think it's working. So take a look at where the mouse cursor is right now. It's dead center. I right click and hold, and I move a little bit, and I let go. It's still dead center. And we might run into a little trouble with the edge. Or no, maybe we won't. Maybe it'll be fine. Okay. I think that's working exactly as we want. This follows more in line with how Unreal Engine does their controls, and less with how Unity does. Because as we were talking about yesterday, in Unity, when you have the click and drag and you go outside the bounds of the window, it still runs, but your cursor still moves, but your cursor wraps around the edge of the screen. And instead, I think that it's a little bit nicer to do like this, where we trap it. The mouse doesn't move from where you clicked and dragged, and so on. Now there is this one little hiccup, and that's actually starting to be a real problem now. I can right-click and drag in other areas of the view while the window is in focus, and we would still get the behavior of clicking and dragging inside the window. I need that to stop. It doesn't seem to happen when I right-click on the tabs, because that changes the focus. But I need right-clicking outside of the scene view to not affect what's inside the scene view. So we can actually re-implement some of the code that we wrote before for this purpose. And that would be to add the invisible button back over the view area. like that. And then when we go to do the right mouse button down, we will only execute this code if is item active, it returns true. Wait, here. Actually, it would be is item hovered. So the idea here is that we set a invisible button over the content area, calculated the same way that we calculate the rendering space. And then if the mouse is over that window and we right click, then we execute this code. And I'll set this down. No, I'll set this up here. Let's try that out. Open the scene. Okay, so while the window's in focus and I right click on it, seems to be working as expected. I right click out here, the focus is still on the scene view. I can still move with the arrow keys. Oh, I can still move with the arrow keys. I'll come back to that. But the point is that it's still in focus, but when I right click and drag out here, it doesn't actually do anything. I have to click and drag inside the middle. So that's working good. It's occurring to me though that the arrow keys should only move the camera when you're clicking and dragging, and right now it just does it whenever the view is in focus. So let's fix that. Let's do that now. That's probably actually really straightforward. We just cut out the code that we were using to do the camera movement, and we will only do it when we update the camera pitch and yaw. Except for that should be below this calculation. And for that matter, it should probably be below the mouse trapping stuff. Okay. Okay. And I'm doing just a little bit of rearranging here. Cool. So we'll trap the mouse right away. We don't actually need the mouse delta in terms of the cursor movement at all. So we can just do that at any point in time. We'll start by doing it at the top. And then down here where it says was right mouse down, below that, we'll do the camera pitch and yaw, and then we'll do the movement, and then we'll actually set the camera. So I think that's it. I think that's probably a fully functional controller. Open scene. Cool. Clicking and dragging. When I'm not clicking and dragging, the ASWD keys don't do anything. When I'm clicking and dragging, they do. They don't do anything either when I click and drag out here. So I think that's it. The only thing left to worry about is the focus of the scene view. Actually, I'm really digging how this is feeling. Yeah, so the only other thing to worry about is when we're in focus or not. So there's two situations we need to think about. If we have some other window focused and we right click inside of the scene view, it doesn't gain focus. And vice versa, if we're inside of the scene view and we right click and drag. Actually, you know what? I think I'm fine with the vice versa. It's specifically when we are out here and we right click in here and we expect it to do something and it doesn't. So how do we gain focus by right clicking inside the view? I don't know the answer to that. I'm going to take a little bit of a break. I'll come back in like, I don't know, 10 minutes or something, and we'll see if we can't find the solution to that problem. But yeah, this is looking pretty nice. I'm pretty happy with what we got so far. Alrighty, I'm back. Sweet. Just checking my levels. It's looking good. Alright, so where did we leave off? So we've got a pretty decent scene controller thing going. Assembled from essentially raw input. I have to gather the raw input myself for use in this code. And I have to do the mouse trapping myself, but it's working. We got a system where we can right click and yeah. Oh, that's interesting. Hang on, I just identified something else that's a little bit weird. If the window is in focus, but I right click outside of it, the problem before was that it was still responding to input, but now when I move the mouse inside, it fixes the mouse position to the edge. I can still move the mouse outside of it. That's probably not expected behavior. Let's make a list of these little quirks that we need to worry about. So there was the one that we needed to worry about that I mentioned before the break, and that was specifically the right-clicking into the view while it's not focused. Should give it focus. So you can immediately go from working inside of the inspector, for example, and then just like right click and then immediately be moving the camera. That needs to happen. Man. All right. And then there's the issue that I just found. If I right click outside of the view and move into it, the camera's moving around. That's not great. The first issue is probably the easier to address, so we'll start with it. With the right-clicking outside of the view, we'll probably just need to rearrange the hierarchy of our condition checks to make that to work, but that's probably going to be require more thinking than the first problem. So first, let's see if Dear I Am GUI has the ability to do this online. These are probably not questions that these are probably questions that most folks have. Right-clicking in the void won't disable focus. In our editor, right-clicking on the 3D viewport opens a context menu handled by Windows Presentation Foundation, not I Am GUI. Also, dragging around the 3D viewport while right-clicking rotates the camera. However, when an I Am GUI text field is active, right-clicking outside the I Am GUI windows will not make the window lose its focus. Want text input is still active and blah 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 blah. Okay. Correct. Right-clicking is not stealing focus it is intended by design, as commented in New Frame. With right mouse button, we close pop-ups without changing focus. Kind of seems like in order to add this functionality, people needed to fork the Dear I Am GUI branch. And I do have a enterprise-specific fork of Dear I Am GUI. So it's not like it's a huge deal for me to have to implement my own fix, but it feels a little bit like this should be possible from the framework itself. That's not so straightforward then. Let's take a look at the imgui.cpp, see if we can spot the comment that he's talking about. Okay. With the right mouse button, we close pop-ups without changing focus based on where the mouse is aimed. Instead, focus will be restored to the window under the bottommost closed pop-up. The left mouse button path calls focus window on the hovered window, which will lead new frame to close pop-ups over window to trigger. New frame, close pop-ups over window to trigger. Fine. Okay, so if the right mouse button is clicked, find the topmost window between hovered window and the topmost modal window. This is where we can trim the pop-up stack. Not sure what all that means. But we could probably find the left mouse behavior by searching for g.io mouse clicked with 0 as the parameter. And here it is. Click on empty space to focus window and start moving. After we're done with all our widgets, so e.g. clicking on docking tab bar will have set hovered ID already, and I'll get us here. Okay. There's also the widgets. .cpp has a couple of references. Okay, I don't think it's in the widgets.cpp. I think what we're looking for is here. Click on empty space to focus the window and start moving. What window is close pop-up? Start mouse, start moving window. Cancel moving if clicked outside of the title bar. Cancel moving if clicked over an item which is disabled, or blah 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 blah. Clicking on void will disable the focus. So it looks to me like the thing that actually gets the focus of the window in IMGUI is this method, start mouse moving window. So if you were to left click on the window, it would invoke start mouse moving window on the window that you clicked on. And then if you clicked on the title bar, it will, after the fact, disable it. But when you go to start mouse moving window, the method that is being used here, start mouse moving window, we invoke focus window on that window. So yeah, that's interesting. What we could do is we could invoke start mouse moving window on the hovered window when we right click. That'd be one way to approach this. But what is clear is that I'm probably going to need to do some experimentation on the whole right click, using right click to focus the view. So I'm going to put that on the back burner and move on to item number 2. Item number 1 I'm probably going to deal with later today while I'm offline. So the item number 2 was to right click dragging from outside of the view. So when we go to right click and we move the camera into the view, it sort of, it's awkward. It quasi traps the mouse, but I can always get out of it. And for that matter, I can escape by, if I right click on the edge and I move the mouse fast enough, I can escape. Yeah, so we got some problems there. Let's take a look at that code. Go back to the scene view. It seems like the invisible button trick is not working here. At least not in the location that we place it. Because is item hovered, is item hovered is checked before we reset the mouse to its previous position. Let me close out of the editor. So with that code missing, if I was to open up a scene and then try to escape by clicking and dragging right on the edge, I can't escape by moving the mouse fast anymore. And I think that's because even though the mouse delta would have moved the cursor outside of the frame, we don't actually escape the bounds of the hovered box. So we don't ever leave the camera control mode. However, that leaves us completely exposed to right-clicking outside of the view. Or on the title bar. So perhaps if we have the view in focus and we right-click, I think we're going to need to reverse our concerns a little bit. So the first check that we're doing is whether the window's focused. I think that should stay, because if it's not focused, then nothing else matters. We then check to see whether the right mouse button is held down. We should probably start by checking to see whether we are inside of whether the mouse is inside the view. Let's try that. So I'll make the invisible button available again, and I will Oh, you know what? Actually, I think I might have spotted a nice way to do this. I will check to see whether the mouse button is held down first, and then we will create the invisible button. And if we were hovering over it, so if IamGUI is item hovered, this means that we know that we're holding down the right mouse button. If the mouse button is being held down inside of the viewing area, then we trap the mouse and do the rest. I think. No, that's the same situation I was in before. Let's look at the app again. Okay. So, so at the time we go to right click and we get the position of the cursor to trap the cursor to. That's right down here. Was mouse down. Trapped mouse position equals I'm going to get mouse position. We could at that time identify whether we're inside the bounds of the window. So you could say inside of here, we would add the invisible button, and then we would check whether we're inside of the bounds of that button. If IamGUI is item hovered, and if we are inside the bounds, then we will set trapped mouse position and set any state that lets the rest of this check continue. I'm going to move the was mouse button down setting into this block. So if the right mouse button wasn't down and is down now, we will check whether the click was in. So the frame that we do the right click, we check to see whether it's in the bounds. If it is, we trap the mouse position and do all the rest. I think we need a static bool is trapped. So this logic executes only on the frame that you click. And at that time, if we clicked within the bounds, we set is trapped to true, and we set the position that we need to reset to while we're trapped. Then for the rest of this code, The rest of this code can go inside of a block, conditionalized based on whether we're trapped. So we'll say if is trapped, we'll do the rest. Okay, I think we're making progress. And then if the right mouse button is not currently held down, then we always set is trapped to false. Okay, I think that's right. Yeah, I think that's good. Let's try it out. I need to close the window first though. Okay. And F5 to debug, please. All right. Open scene. Test 2D scene. All right. So now we got the window in focus. If I right click outside, it doesn't do anything. If I right click outside and drag in, it doesn't do anything. If I drag out really fast from the edge, it remains fixed. I think this is it. I think this is the solution. So now it seems to be clicking and dragging correctly only when we're inside of the bounds, using that invisible button. And if the window's in focus and we right click outside, we maintain focus on the window, but it doesn't start to drag the camera when I move it inside, nor does it activate the keyboard and mouse. Perfect. I think this is actually exactly what I wanted. The only sticking point for this controller that I don't really like is that I have to left click into the window. And I'm not really sure how best to approach that. Out of curiosity, I'm wondering whether there's any weird gotchas with the game view crossing over. Doesn't seem like it. Seems like I have to have the... Yeah. Seems to work fine. The controls being passed from the scene editor and the game view pretty well. Though now that I'm thinking about it, I probably want the game view to get focus if you right click on it as well. So I'll need to come up with a way to pass the focus to a IMGUI window if I right click on its content area. And that probably, for now, that's only going to be useful for the game view and for the scene view. But in the future, I may want to have multiple scene views or multiple game views. In those situations, we'll want to be able to set those windows to focus when you right-click on them as well. Yeah, okay. I'm thinking this is probably a good stopping point. Everything seems to be working well. The game view works exactly as expected. The camera is working quite well inside of the scene view. We can open and close scenes perfectly fine. Yeah, so this is a pretty productive session. I'll probably take a look at the IMGUI problem later today while I'm offline, because that's probably just going to be a bit of research, basically just me reading stuff. And then from there, once I've got that solution figured out where I'm not trying to move the camera and then not able to because I haven't left-clicked yet, once we're at that point, we'll be talking about actually editing the contents of the scene. So right now we can move the camera around inside of a loaded scene file, but to actually have the entities display in the hierarchy panel, and then have the ability to make changes to them with the inspector. That's the juicy stuff. That's where we're gonna try and go next. Thanks for tuning in. I hope this was educational. Have a great rest of your day, night, or whatever.